to welcome Jeyaram Srinivasan sir, and I am also happy to welcome all the participants for this webinar. I will give a slight introduction about for the benefit of the outside attendees. Some of the industry persons are attending and some of the students from other institutes are also attending. So for benefit of all, I'll be giving an introduction. So this is our institute, All India Sri Shivaji Memorial Society campus in Pune. Ours is a premier heritage group of institute which has been established in 1917. We are very much blessed with dynamic management. Sri Shahu Chhatrapati Maharaj, who is the president of AISSMS Society, Sri Sambhajiraje Chhatrapati, who is the vice president of AISSMS Society, Sri Malojiraje Chhatrapati, who is honorary secretary AISSMS Society, and Sri Suresh Pratap Shinde, who is honorary joint secretary of AISSMS. And as you can see, our vision is to uplift the common masses by rendering value-added education. So this webinar is one of the steps for doing this, giving value-added education. And we get all this support from our management as well as our principals, sir, for doing these kind of activities. They always promote these activities. Just to give introduction to our department has started Power Quality and Energy Conservation Cell. And in that we do a lot of activity which are beneficial not only for students but for the industry as well. So we provide power quality training. We give power quality audits. In power quality audits specifically there are harmonic audit, reactive power audit, transient audit, power quality consultancy. We are also into energy and power quality monitoring system. And one of the main important part from where everything starts is the electricity bill analysis. So we have electricity bill analysis. We have state-of-the-art equipments, including 4 Class A power quality analyzers, which we use for our students' projects as well as for the consultancy. And I make it a point to take my students along with me for consultancy so that they can get a hands-on experience. Coming to today's speaker, I am very happy to introduce J. Srinivasan sir, who is the partner in Enablers LLP Chennai. He is a graduate in physics from Madras University. He has also completed PGD-MM and he has a vast 42 years of experience in the area of motor dimensioning, motor testing and inspection, on-site efficiency testing and analysis of motors, power quality audit and solution for harmonics and voltage quality, training and orientation, energy conservation, and he is a recognized national level energy efficiency expert. I have attended almost all of his webinars since last 2 years, and for many days we were discussing about this webinar, and I am happy that today we are able to make it. So welcome Srinivasan sir. I'll give before I hand it over to Srinivasan sir, and I will be also requesting our principal sir to say few words. I'll complete first instructions. All the participants, please mute your audio, also stop video if it is on. For the best results, please use headphones. If anyone wants to ask question directly to the speaker, please click on the raise button. We will unmute you during question answer session, or if Jeyram sir permits, in between also we can have discussion if required. Alternatively, you can post your questions in chat section. Feedback link will be shared at the end of question answer, which will help us to give you e-certificate as well as presentation if shared by the presenter. And feedback link will be closed after 30 minutes. So thank you all of you for joining today. Before I request Jeyram sir, may I request our principal sir to say a few words, sir?
Thank you, Shelar sir. First of all, a very good morning to all the participants who have gathered for a insightful webinar which we will be having by Mr. Jeyaram Srinivasan. To take this opportunity to welcome our today's on behalf of our All India Sri Shivaji Memorial Society management and the I also like to thank Sachin Shelar sir and his team for organizing this seminar. The need of the hour that today the should be awareness programs about power and the energy conservation. And I think that Shelar sir and his team and the electric department is contributing a lot to all these activities. And as a part of this, today's webinar is also awareness program, which I hope all of you at the end of the webinar will surely take home with you something which is more relevant to you, and maybe will give you at least a way of thinking as to whether you should move into this field, or maybe if it is industry, it will be useful to know the expertise, the speaker who is going to deliver the content, and also it will be beneficial for the students also. With this, once again, I would like to thank our today's speaker, Mr. Jeyaram Srinivasan, for agreeing to deliver this speech. Thank you, sir. Thank you all. Thank you.
Thank you very much, Dr. Mane sir. Now, may I request Jeyram sir to start the presentation? As discussed, we have students and industry person as well as faculty members. Yes, sir.
Can you see the screen?
Yes, sir. We are able to see the screen.
Good. So hopefully you are able to see my video also.
Yes, sir. We are able to see video, your presentation, as well as you are audible clearly.
Thank you. Sachin, I must thank you personally for this opportunity, first of all. I also thank the college, the principal and the management for this opportunity. I hope the next 1.5 hours that we are going to spend together is meaningful and useful to you. I do not know exactly what is the pace required, the speed with which I can make my presentation, but I'll try and be as distinctively clear as possible, because I understand the majority of the participants are students. There are also people from the industry, there are staff. They will understand the techniques that I'm talking about, the topics that I'm talking about. But the practice is what is very important. So my suggestion to the participating students is to follow, note down what is not clear. If it is too technical, then I will depend on your college staff, people like Sachin Shelar, to give you an insight into those topics. If it's something that I can clear from out of what I am presenting, I will be very happy to clarify during the question and answer. Try and keep the pace going so that we don't interfere the presentation. My suggestion is keep your questions either in the chat box or raise your hand, so that during the Q&A, I will be able to find time to answer them. The first 10 slides are basically, I'm trying to put people in the picture, in the broader picture or in the broader perspective, so that we are able to understand the importance of this presentation and what is the real benefit that can come out of this presentation. So the slide 1 talks about our present population. There was a time when India used to struggle with the population, but today we are actually in pace with the Chinese population. We will be out doing them, and we will be growing beyond the Chinese population in a few years from now. What is very important for us to understand with this population is the understanding that 65% of this population is younger population. So in that sense, India is the youngest global population today. That is a strength in itself, as you might agree with me, because these people below the age of 35 are the most aspiring. Therefore, there is a lot of dream, there is a lot of achievements that is waiting to happen, and I expect this younger population to contribute for our growth, for our development in a fashion in which the other countries will be unable to keep up with. In terms of economic growth, also India is on the right path. As you can see today, it is approximately 2.94 trillion economy. We will go on to become 5 trillion economy as per the projections given by the government by 2022. It may suffer because of the pandemic that we are having since last year. There will be a setback, but then if you can read a lot of research and studies that are being shared, India has a growth potential to be a $5 trillion economy sooner than expected. The growth is the highest. So as you can notice from many articles, India is poised for a bigger growth. Now, urbanization is the engine which will push the India's growth. As you can see here, India is far below the world average of 55.3% of the people living in urban areas. We are still a rural population at 34. So we have a very good opportunity to grow and surpass this as we move along. So urbanization or Paris is going to be the future for India. The life of the people, aspiring people, with all comforts, facilities, and education and things like that will be in the urban areas. So India's population pace of urbanization will see a result of urban population exceeding the rural population by the year 2050. So this is the growth that is likely to happen. So with this growth comes the challenge of finding jobs. Now, I for one is given to the idea that engineering colleges are here to stay, because the future of jobs is going to be extensively for engineering and graduates, normal graduates from the colleges. So education is going to ensure that we get our desired jobs and desired careers. So engineering graduates have, in that sense, a greater potential, greatest of all potentials available as per the studies done in 2019 and 20. Many of you might think that engineering education does not give you the jobs, but then that is not the truth. Engineering education and engineering career, in my opinion, is like a long distance marathon running. It is not a 100-meter dash. Like you join in 5 years time, you reach a situation where you don't know what's going to happen for your future, and you are already contemplating self-employment or retirement and so on. So as you can see here, the demand for experienced candidate is definitely higher. Fresh graduates in the demand pool are only about 15%, whereas 85% are from people who have experience and knowledge. So therefore, very important that you have to understand that this is a long distance marathon running. Put a sizable number of useful years in generation, in knowledge and in experience, so that you are eligible for better jobs as you move forward. The survey also indicates 5 preferred skills in a candidate while hiring. Very interesting to note that nothing talks about knowledge. They talk about attitude, adaptability, learning agility, domain expertise, and interpersonal skills. Domain expertise will come only with experience. Therefore, you have to have patience, wait for your turn. Future of jobs has got good potential for engineering graduates in this country. And the kind of emerging jobs in the next 5 years, you must have already noticed, and many other people would have already spoken to you, are in the area of data science, analysis, digital marketing, robotics, process automation, human-centered design, compliance, and so on. So this slide will give you a general idea, probably a confidence in what you are doing. If you have come here to do engineering courses because of the compulsions of your peers or your parents, please don't fret. This is a good opportunity for you to put yourself in a higher echelon in this society. Wait for your turn. Remember that it is a long-term marathon, not a short-term dash where your career ends in a, if you permit me to say this, I will say this, IT jobs which are going to the core sector engineers is a short-term, euphoria. It will die down. So therefore, my suggestion is please equip yourself for jobs in the future, which are suitable for your learning and your skills. So along with the urbanization, which I mentioned to you as the future for India, our power generation, our power demand also is keeping pace. It is ever increasing. This one slide will give you an idea about what it was when we got our independence in 1947. Only 1,362 megawatt was the power generation for the entire country for you to appreciate this information, you should understand what is it today for NCR, National Capital Region, which is Delhi and a few cities surrounding Delhi, like Gurgaon, Faridabad, Ghaziabad, and Sonipat and so on. So NCR's today's requirement is approximately 11,000 megawatt. Chennai, a city from which I come, has a June-July requirement of 2,500 megawatt. Just imagine, in 1947, most of our parents and grandparents would have lived in darkness. After 6, there would have been no power. Just 1362 megawatt was the generation, and we were largely agriculture dependent. More than 80% of our population was living in rural areas. So from there, we became an industrialized nation. Industrial economy pushed the demand, and today, as on 31 March 2021, our generation capacity built is 3,82,150 megawatt. Almost everything is built post-independence. And the projection by 2030, a lot of articles are written on it. Number of companies have given their research and findings. By 2030, if the GDP growth as projected keeps pace, and if we don't have many more pandemics, our generation capacity is likely to double to 8,17,254 in less than 9 years. It should double or slightly more than double. This is a data published by the Central Electricity Authority. So this is also going to keep growing, because today we have 5 metro cities. By 2030, the estimate is we will have 16 metro cities. I'm sure Pune will become one metro city. So metro cities means there will be a lot of demand on power for transport, for education, for buildings, for entertainment, malls, and so on and so forth. So this growth is not possible to be stopped. So this growth is definite. This growth is supposed to keep up with whatever growth that we have in population growth, aspirational growth, dreams, and so on and so forth. But then a word of caution. We all of us have to understand that this growth does not come without a price. If you look at the population in 20th century alone, our global population tripled. So what we used in 20 centuries all put together, or 19 centuries all put together, we used up in 1 century, which is 100 years. In the 20th century alone, we used up equivalent of what we used up till the 19th century. This is the danger of exploiting all the resources. The estimated reserve for coal is about 130 years. The oil reservation, oil availability will be less than 50 years. We have to find alternate fuels. That's what is happening now. Electrical vehicles are now growing in a big way. What is abundantly available, however, is the non-conventional or renewable energy, like biomass, solar, wind, and nuclear. So we need to grow in this area. You might be recalling that the government of India has a very ambitious plan to put up 1,75,000 megawatt new and renewable energy in solar only. This is the goal that India has proposed, and they are proceeding in that direction. What is also important for us to know is that the other resource which is very, very important for the livelihood of the human and animals in this world is fast depleting. There is a statistics which says that only 2% of the global water is potable as it is. Otherwise, it has to be treated, and then we'll have to drink it. So we are going to run out of water even before we are going to run out of oil. So these are dangers, and that is the reason why energy conservation and energy auditing or energy efficiency are very important for our country. So my aim with these 10 slides is to try and put you in the picture, the larger picture, that India has growth potential, growth aspirations, population growth in the available facilities, and so on. But at the same time, the growth comes at a cost. There is a danger of our losing natural resources, and we have to depend heavily on renewable energy and other opportunities, and energy auditing and energy conservation. people say that approximately 25% of what we are using in the industries are savable. We need to save 25%. We could possibly start small, start with 5%, 8%, 12%, 15%, and so on, and go on to adopt the complete latest technologies which will give us the energy efficiency measures. So today, after these 10 slides, I'll be going into a few cases of my own experience. I'm trying to tell you here that I am not here basically to teach you. That's not my job. Your college has got faculties who are qualified enough, experienced enough to teach you, give you a prescription so that you know what you have to learn, and all you have to experience in the first 5 years of your career will help you to shape your career. But I'm here to basically interact with you, exchange ideas and knowledge as an academy versus the industry interface. So my aim is to interact and not to educate. So I will proceed further into the topic for today. Like I said, energy auditing, whatever type of energy auditing that we talk about, as you all know, it's considered as an interference by the industry. Some of you people who are coming from the industry will be here. Although I'm not able to see each one of you, I'm sure you will be nodding your head in acceptance. Energy auditing, or any auditing for that matter, internal or external, is seen as an interference. People don't like to be audited, they don't like to be examined, they don't like to be informed about their faults or folly. Therefore, in that sense, auditing is unwelcome. But then it is an area which is very, very critical and important for people to proceed further with whatever they have been doing. To start anything, we need knowledge. To continue to do whatever we want to do, we need conviction that we are in the right direction. So we need somebody, third party maybe, to come and tell us where we are going wrong, and based on the priorities that you have within the industry, you will be able to undertake and rectify defects if there are any, and then move forward. If the finding of an audit says that your work is good, exemplary, then you have the conviction to continue to do it or do better. So this is my idea why an audit is very important. While audit is being discussed, this broader perspective on what is available for saving is also critical for us to understand. A pyramid, as you can see, is broader at the bottom, narrower at the top. So as you can see here, energy conservation is the most important and it forms the foundation. Conservation means reducing the usage. Energy efficiency means reducing the wastage. So energy conservation is putting off what is not required. Energy conservation is optimizing what is actually to be used. Whereas energy efficiency is adopting new technologies, reducing losses in conversion of energy from one form to another form. Like in the case of lighting, as you know, from the incandescent to LED. There is an organization called EESL. You will be coming across this name often because they are the ones who are now ushering in a lot of energy efficiency technologies in India. For example, LED bulbs, they've identified that 80 crore incandescent bulbs, which are very energy inefficient, have to be replaced with LED bulbs. They have come with a ESCO model where they have gone for, excuse me, large-scale tendering process for procuring these bulbs and supplying to different states and municipal corporations and so on. They have crossed almost 40 crore bulbs. 50% of the target for our country is already crossed. And they are also into various other activities. You may have come across 5-star labeling, which is by the Bureau of Energy Efficiency. So they apply 5-star labeling to appliances like air conditioners, television, they have for fans, small pumps, refrigerators, and so on. So energy efficiency has a huge potential to be adopted in this country so that the old and inefficient devices can be retired and energy efficiency can be adopted in a big way. Electric motors. are one area where I work very closely with the ESL. The potential expected to be is about approximately 1.5 crore motors. So that is the kind of area in which ESL is working. And the top of the pyramid is the adoption of renewable energy. We saw the importance of it. The natural resources which are undepletable should be used extensively so that we build our future growth in energy on the basis of requirement of energy. You may have noticed that the name of my company is Enablers LLP. LLP is actually limited liability partnership, is another form like a private limited. Enabling is our job. So ACE is actually an acronym standing for Energy Accounting, Energy Conservation and Energy Efficiency. So you find ACE expanded like this. I have got 2 slides on accounting. I'm not going to, most of my slides will be directly talking to you about topics and opportunities. If you have doubts on the topics, I request your college, staff, your faculty to enlighten you and expand your knowledge and understanding. If you have doubts on some of these points that I'm making, you are welcome to raise your hands or raise your questions in the chat box. So when it comes to energy accounting, I have got 2 slides. I have put in front of you, after masking the name of the consumer, an electricity bill from the Tamil Nadu Generation and Distribution Corporation, TANGEDCO. Right, this is sometime in 2013, but then this is, reliable. This is important enough to discuss even today. See, the demand, sanction demand for this industry, for this facility or the consumer is 2,100 kVA. And they're actually paying a demand of 1,890 kVA. So if you put 1890 divided by 2000, you will come with 90%. So this is what in an electricity bill they do. Up to 90%, whatever is your actual consumption, you have to pay this 90%. Above 90%, you will pay the actual. Supposing your consumption is 92, 93% of your sanctioned demand or permitted demand, you will pay that value. But if your sanctioned demand is less than, your actual demand is less than 90%, you will still end up paying 90%. Let me go back and forth with the next slide so that you will be able to understand this. See the demand here, the actual demand reached by this customer is 1764, which is 84% of the sanctioned demand. But still they are paying 90%, which is what is the, the rule for, as per the tariff. So this is one area where 1890 is 90%. So 2100 is sanctioned. So what happens here? We are actually paying 336 kVA additionally. At that time, this was 300 rupees per kVA. Today is 350 rupees. See, it's 2013. So it is 350 rupees per kVA. So approximately 1 lakh rupees every month they are paying for an additional demand. So the first step this industry should do, or this facility should do, is to surrender unwanted kVA and manage their kVA appropriately. That is the advantage of doing a energy accounting with the energy bill. So any energy auditing, as you enter the industry or enter into an agreement with this industry for your services, what you should do is to collect the last 1 year energy bill and address the energy bill in such a way that you understand what is really happening. So this is one potential you have. Approximately 1 lakh you can save without doing anything, merely by surrendering the kVA. So energy accounting will help you understand that better. The second thing is, if you can notice here, 6,84,000 is the consumption for that month. Now, if you divide it by 30 into 24, this is 24 hours, 30 days. It comes to 950. And if you look at the power factor of this facility in that month was 0.96. So 950 divided by power factor, 950 kilowatt divided by 0.96 power factor will give you 990 kVA. This is the average demand for this consumption. But then the registered demand is 1764. So you can appreciate that there was a peak while some of the internal large machines have started. The demand peak was registered, and therefore they have 1764. But in reality, this kilowatt hour, if you divide it by 30 into 24, you get only 990 kVA, which is only 47% of the load factor of the connected loads. So therefore, if you are able to educate the industry as to how they can avoid this, sudden shoot up in the kVA also, you will still be able to reduce the kVA demand. So kVA management is critical for reducing a very important part of your bill. As you can see here, total energy charges for this units, number of units, 6 lakhs units that we saw, considering various, tariff on the time of day. They call it as time of day tariff, like normal tariff, peak hour tariff, and night hour tariff, which is a rebate of 5%. You will get so much of value. So if you know the industry intrinsically well, you can also discuss with them regarding deferring some activities to the night shift, where you get 5% rebate instead of doing it in the day shift. So if you know the process, if you know the flow of work, and if you can discuss with the process people or the management of the industry, it is possible to defer certain activities to a tariff where you get a rebate, so that you will be able to save on this energy also. So energy accounting basically talks about kWh management, kVA management, and the reactive power management. Now, we do not have power factor incentive in many states. I'm sure even in Maharashtra, power factor incentive is taken off. And what is not discussed at that time in 2013 is a penalty for harmonics. So we'll discuss that in a separate thing, but sufficient for me to bring out these two information in these 2 slides regarding energy accounting. So therefore, when you talk to an industry, there are 3 opportunities available so far as the cost options are concerned. One is the low cost solution, second is the moderate cost solution, the third is the high cost solution. Whatever suggestions that we make to the industry should be able to participate, interact with us, understand and agree to implement. I must say here, most of the energy auditors who do this audit and submit a proposal find that their audit proposals lie without getting implemented. This is a sad part of the story. Bureau of Energy Efficiency, just a word I want to talk about Bureau of Energy Efficiency. India is the second country to enact a separate law for energy efficiency. In 2001 in the parliament, this law was enacted, and in 2002, they formed the erstwhile Energy Management Center, EMC, as Bureau of Energy Efficiency. India is the second country after America to introduce a separate bill for energy efficiency. And Bureau of Energy Efficiency came with a lot of ambitious plans. You can go to their website, spend some time trying to understand what they are trying to do. You must have come across some of you already, like the labeling program which I mentioned to you. The implementation is taken care by the EESL. EESL itself is a public sector company formed by 4 public sector companies under the Ministry of Power, like NTPC, Power Finance Corporation, Power Grid Corporation, Rural Electrification Corporation. So government is creating a lot of efforts to not only create a policy for energy efficiency, but also implement and help the industries and domestic or commercial establishments to save energy, put less energy to use for the same job done. So Bureau of Energy Efficiency also came up with energy auditors and energy managers courses through which they certify. If I tell you, you'll be surprised. The target at the time when they announced this as a program was 7 lakh energy auditors in this country. 7 lakh. Today, I would imagine only a few hundreds, maybe 2,000 or 3,000 people may have passed the energy auditor course. Half of them don't practice, half of them practice, and what they practice, people don't adopt or execute. This is a sad thing in our country. we need a lot of push for us to do this exercise, and that's why they came with PAT scheme. Some of you who are interested can read about the PAT scheme, Perform, Achieve, Trade. What they did is they identified some 13 sectors over a period of last 7-8 years under PAT cycle 1, 2, 3, I think 4 or 5 is right now going on. Under the PAT cycle, they have identified energy intensive industries and given them targets for energy saving, approximately 15% targets for each of them on the basis of the metric ton oil equivalent they burn. All the types of energies, all the types of fuels are converted finally into oil equivalent. So metric ton oil equivalent has been fixed as the targets, and any industry which is exceeding after an audit is compelled to carry out measures to save energy. And Perform, Achieve, Trade PAT schemes has been a push effect. It has helped a lot of industries to practice this. But otherwise, in general, people who aspire for energy conservation or energy efficiency improvement don't really give the right kind of impact for the suggestions people make. People should make low-cost solutions or low-hanging fruits. Anything that can be achieved without much of investment, like best practices, discipline in the working, energy conservations, and those things can be adopted easily because people will like no investment but good returns. So low-cost solutions are equally important. Moderate cost solutions, some moderate people have come forward to apply this. For example, I can tell you Mahindra in approximately 12 plants across the country have gone for almost 2,000 motors, IE3 motors replacement after finding initial pilot study, and I conducted a 3-hour program video conference like this. After that, they went ahead and then procured and replaced most of their old inefficient motors, nearly 2,000 numbers in 12 plants across the country. So those are moderate solutions where the payback, return on investment, is less than 3 years without considering the salvage value of the old equipment which they remove from service. High cost solutions definitely require a lot of participation from the higher management. So when we make an audit suggestion, we should identify this ourselves as low, moderate and high investments and returns paybacks and things like that, and then make a proposal to the industry which we are doing auditing. Now I'm getting into the area where I have shared a lot of my case studies and experiences. I'll try and be as slow as possible so that you can catch up with me. Wherever you have doubts, please write to me. Even after this program is over, I am willing to engage in correspondence through mail. So my last slide will give you my mail ID. It will also give you my mobile number, but my request is please don't call me, because most of the time I am engaged in programs like this and my mobile is either switched off or is in silent mode. You will curse me for not picking up your calls. So we'll go and further discuss regarding electrical system and power quality audits. I have carefully chosen some slides which will give you both bari mein in turns, so that you are able to understand this better. So when you discuss about an industrial electrical distribution system, it's a very simple single line drawing that I have shown here. Very complex single line drawings are also available in industries where you have power transformers followed by multiple distribution transformers and MCCs and PMCCs. I'll give you an example. Chennai Petroleum Corporation Limited, CPCL, has approximately 70 distribution transformers, almost 14 power transformers. So that's a very complex SLD. For our easy understanding, I have used a very simple SLD where there is one transformer which is receiving supply from the electricity board from 11 kV, converts it into 440 volts. So the point of common coupling, very important for us as we progress, we'll be discussing this. Point of common coupling is the trivector meter. Beyond that, it is a EB property downstream of that is our property, the facilities property. So the point of common coupling is very important. We have to identify this. Standards like IEEE 519/2014 very clearly talk about point of common coupling as being the place where the standard is applicable. The standard is not applicable elsewhere in the distribution network. It is applicable only at the point of common coupling. So we have a transformer, we have breakers, then we have a 440 volts bus in which various motors are tied, and as you can notice, they go on to coupled with fans, blowers, pumps, compressors, lighting, heating loads, and so forth. These are the end-use loads. So this is the installed load. This is the end-use load. So as you can see here on the right-hand side, I have circled importantly the losses as it exists, as found by. This is a slide by Terry, the Energy Research Institute, which is based in Bangalore and Delhi, which is a very leading organization so far as the energy auditing and energy policies are concerned in our country. So as you can notice here, transformer efficiencies are between 98 to 99.5. Distribution losses are between 1 to 6%. And the motor efficiencies are between 85 to 96%. 85 will be for average low rating motors. We call them as small motors. And 96 could be for very large motors, like 160 kilowatt, 200 kilowatt, so on. So motor efficiencies are ranging between 85 to 96%. So you will understand from this slide that in these three areas, so far as the electrical system is concerned, the potential available for energy conservation are explained, so that we are able to apply in each area and then understand how we can make energy saving. So when you go as an energy auditor or as a team of energy auditors, your observation, your participation, and your experience will count in understanding these areas which are available for energy conservation or energy efficiency improvement, and then you will be able to make an impact with your report. So when you look at the electrical system, like I already mentioned to you, you have installed distribution system and operating electromechanical system. The examples are transformer, bus bars, cables, switches, fuses, contactors, relay, etc. And the motor systems, electromechanical systems comprise of motors, motor systems like gears, heaters, lighting, fans, pumps. Those are all electromechanical systems. Now, how to reduce the losses in electrical system? A simple rule of thumb has been suggested here. In the installed distribution system, the losses are basically I2R losses or line losses. So what are we left with? We can't go and reduce the I. When you suggest to the process to reduce I, you are suggesting them to reduce the productivity. You can't reduce the productivity efficiency in order to achieve electrical efficiency. So you have to ensure that this I is not reduced, but the R can be reduced. R is resistance. How will you reduce R? Solution is in one simple word called upsize. So when you have a switchgear or a cable or a bus bar, if you increase the cross section or increase the number of number of bus bars and number of cables, then you will be able to reduce the resistance. So this is what I mean by upsize. So for the installed distribution system, upsize is one opportunity available to reduce the I2R losses, because we will be reducing the resistance. So a few slides are there where I have explained this in detail based on our studies. So far as the operating electrical mechanical system is concerned, the losses include copper and iron. Now, one rule of thumb that everyone will tell you is when the two losses are equal, the best efficiency occurs. This is true for motors, this is true for transformers also. For most of the electromagnetic instruments, equipments, the copper and iron losses, when they become equal, the best efficiency happens. Therefore, the solution for operating electromechanical system is to optimize. So we have upsize and optimize. We should classify our solutions under these two. look at the transformer. I have shown you a graph where the typical 100% rated load, excluding harmonics, the losses are here like this. Fixed losses or no load losses, conventional load losses, and extra losses due to harmonics are also mentioned here. Whereas if you are able to lower the rating of the transformer, load on the transformer, not the rating of the transformer, load on the transformer, your I2R losses or stator losses can come down. These are called iron losses, these are copper losses. These copper losses can come down dramatically. So the ideal choice for a transformer is to limit the operations or loading to 50 to 60%. It is the most economical load because most of these transformers have an efficiency curve like this. So their best efficiency happens, oil-cooled transformers particularly, happens around 40%. So beyond 40%, the efficiency keeps dropping. At 100%, you will see the lowest efficiency occurs. So you have to optimally load the transformer. The economic load factor is between 50 to 60%, where the drop in efficiency is not substantial. So any book, rule book that you take and read, or any association which is involved in energy auditing, will tell you that the optimum loading or the most economical loading for the transformer is 50 to 60%. Now I have taken the case of a 11 kV supply to a hospital in Chennai. I'll be using about 5-6 slides to bring out both power quality as well as power studies that we have done. So this is a simple one transformer with multiple feeders, load feeders. Simple SLD has been shown here. There are more feeders, but I have limited for the purpose of the slide with a few feeders only, including an APFC 400 kV installed. This is an APFC. I will be later on using word like DAPFC. I will try and explain to you what is the difference between APFC and DAPFC in case you require that information also. So this case is what we will be discussing. There will be about 4 or 5 full day recordings with which we will be able to give you, various parameters and tasks that we have taken to analyze and explain to the customer and propose energy auditing. This is a full day recording using a power analyzer at 6:45 p.m. to next day 6:45 p.m. This is the pattern of the kilowatt load average. As you can see here, during the nights it is low, during the daytime it is high. So this is approximately 283.5 kilowatt. If you remember, it's a 500 kilowatt kVA demand, sanction demand for this industry. 630 kVA is the transformer, which is 1002 kV. So as you can see here, this is the finding that we have with this slide. And with this, we are calculating what is the all-day efficiency of a transformer. Now, this is not an industry, this is a hospital. Industries also, you have two kinds of industries. Like in textile industry will have 24 hours constant power. Whereas if you go to an engineering industry, the average load factor will be less than 50%. Some shifts will be very high energy, some shifts will be low energy. And there will also be long periods of rest in between shift change and things like that. Whereas in the hospital, the requirement is continuous, 24 hours. So what we have done is we have used an all-day transformer efficiency calculation in an Excel. There are two types of Excels that we use. One uses the all-day energy and then arrives at the output kilowatt hour and then works out the transformer efficiency all day. So as you can see here, the average load factor was 23%. The power factor for that day was 0.982 and the all-day efficiency of the transformer was 99.35%. Now I have another Excel here. You can ask for this Excel and take it for your working, where for the transformer with the declared losses, we have worked out what is the peak efficiency. The peak efficiency at rated load, 100% load, is 99.05%. whereas the maximum efficiency will occur for this transformer at 34% of the load, where these two losses are equal. So if you consider 23% as a load factor and find out what is the loss, I-squarer losses, then you will find that it is from 10,750 watts, it has come down to 568 watts because of the low loading. So at 23%, the transformer efficiency is 99.37. So these two figures will more or less agree. This is a static value, which fixed specification, but this is a dynamic value for a full day, all day transformer efficiency. So can we improve this 99.35? No. But can we improve the load factor? Yes. Because in the previous slide we saw that the most economical load factor can be 50 to 60%. So it's possible for this hospital to expand and still load this transformer better and retain this efficiency better. So this is one of our findings. This transformer was originally IS 2026, old transformer. Today you have IS 1180 level 2. Now, in the independent India, no government has given a gazette order for making energy efficiency compulsory in our country. Between 2014 and 2018, two important gazette orders came. One was released by the Ministry of Power, Heavy Industries, which talked about the transformer efficiency. They introduced IS 1180 level 2 as the minimum efficiency performance standard for distribution transformers in India. Today, no manufacturer can manufacture transformer as per IS 2026 classes. They can only manufacture as per IS 1180 level 2. So this will ensure that only high efficiency transformers will be supplied in the industry. Also, the legislation is working overtime to see if the old transformers can be retired. You must have definitely come across things like old cars, automobiles should be scrapped. Similarly, there will be a policy soon in this country where old transformers, which are 20-25 years old but conforming to IS 2026, will be retired, and new transformers conforming to IS 1180 level 2 or level 3 will become compulsory in this country. The second gazette order, GO, was concerning the motors. IS 12615 2011 has been made, IE2 as per that standard has been made compulsory by another GO by the Ministry of Commerce and Industries. Department of Industrial Policies and Promotions, DIPP, came with this GO where they said no manufacturer shall manufacture motors less than IE2 in this country. This was effective 1st January 2018. I can tell you that in 2019 and 20, the growth in IE2 and higher, IE3 or IE4 motors was 99%. Only 1% is the pilferage. Non-IE motors are getting manufactured in this country. So on one side, the legislation is pushing the industries and the user to go for high efficiency in transformers, high efficiency in motors. On the other side, the pull effect is being created by various schemes and programs. Energy auditing is one such measure where customers can be educated, motivated to go forward and introduce high efficiency. So energy auditing in that sense is very, very important because, like I told you, we are responsible for nearly 25% of reduction in energy conservation or energy consumption in industries. This is the same facility, another window. This is the power factor. As you can see here, 0.982 is the average power factor for the day. See, when you talk to Mr. Sachin Shelar, he will tell you what does it mean to read, the data downloading from a software of a meter. So here, the cursor is the point. Cursor is the point at which I have kept the red line. Window is the entire window. This is a 1-day window, as you can read here at the bottom. This is a 24 hours window. So for this 24 hours, the average power factor was 0.982, although the power factor reached 0.995. Occasionally, the power factor was down. See, for example, here, minimum is 0.68, 0.70. So these are the reasons why the average is pulling down from 0.995. So one has to understand which are those loads whose infrequent usage is actually causing the drop in power factor, and accordingly manage this. So when you deal with the customer, you should be able to highlight these informations and educate the customer to undertake measures such that this value will also be reasonably high, 0.9596, so that this will become 0.995. Another window where we talk about the peak demand. In that 24 hours that we saw, the peak demand was 532.3 kVA, whereas the kilowatt was 288.7. So you know, kilowatt divided by kVA is the power factor. So this 0.68 power factor which you saw in the previous slide, 668, must have happened at a time when some such equipment was suddenly started. So I have just marked at 7:15 a.m. in the morning, there was a sudden spurt or jump in the demand that was registered in this time, as you can see here, 532.3. The cursor is kept here. The cursor indicates the peak has happened here. So I asked what happened. They said, sir, we switched on the chiller. So this must have been the time when there must have been some rain, or the chill weather should have been very, very good, and people would have managed with AHUs in the nights. It's a child hospital, so therefore during the nights the temperature would be slightly kept warm. They will not run the chiller. But in the morning, as soon as they come and they start other preparations, other operations and things like that, they would have switched on the chiller. And this sudden switching on, this is a start delta starting. So sudden switching on of this chiller at 7:15 a.m. using a start delta starter has registered this peak. What is the impact of this is that they are paying for 532 kVA. I think the sanction demand is 600. They are paying for 532 kVA, which they need not have paid if they have had a device which will prevent a sudden jump in the kVA. So we proposed a VFD. Even a soft starter will not help, because start delta starting and soft starting are both identical. You cannot limit the starting current to below 4 times. Whereas a VFD can help you to start with even 100% nameplate ampere, and the demand can be substantially reduced. So this is another thing that comes out of the same full day recording. So as you can see here, 240 kVA excess demand has resulted in this facility paying approximately 84,000 rupees more every month towards the additional demand. So this can help them to recover. This will be approximately 10 lakhs in a year. A VFD for this demand would probably cost less than 10 lakhs. So in less than a year, people will be able to recover the investment and ensure that the demand is surrendered what is more than required. So there are two occasions on which the peaks have happened. We have explained this to the customer in our report and asked them to address this. I must tell you, this was sometime in 2019. They are yet to take up this task. Like I told you, most of the advisors are not under priority for many of the facilities. So when it comes to cables, Terry has published a formula. Formula is written at the bottom. You can use this formula in the Excel sheet. I'll show you one Excel sheet next for one of the industries where feeder-wise cable losses has been found out, and we have told the customer to either undertake 2 runs or 3 runs of cables or increase the cross section of the cables. So cables are put to earth, or they are also used in the ducts in the air. Current carrying capacities are higher when it is in the air. Nowadays, the fashion is to use a lot of XLPE cables rather than PVC cables because of the long life. We recommend copper cables because of the pliability and lower cross section, so that the losses can also be minimized. We have already discussed the opportunities available for reducing I2R losses by upsizing the cable sizes or the additional runs of cables. If you look here, I wish I had shown one more slide similar to this. This is a textile mill. Another textile mill has a policy that they will buy only 300 square mm or 400 square mm cables for all their feeders. Typically, 50,000 spindles spinning mill, if you had gone and noticed, will have about 17 to 20 feeders. So this particular mill had not used that policy, upsize. They had reduced the sizes of cables, as you can see here, 3.5 runs, mostly 185 square mm and a few 240 square mm. Now, if you read about the cable selection, spend a little time to understand this, you will have to make cable selections for short circuit current, for reducing the drop in voltage depending on the length and the cross section, so that you understand what is the voltage that has to be applied at the end use loads, motor terminal. So as you can see here, we have done this calculation by using the number of phases, that is 3 phase, number of runs, 3 runs, current carrying capacity, current measured by us during the audit, the resistance from the cable catalogs. We cannot measure the resistance at site because of the length involved and other interferences that we'll be making. So we take it from the catalog. Then the length also we find out from the customer. Then the number of hours of operation in which the industry is switched on or cable is switched on. And a loss load factor we assume as 0.85. And we work out the losses in each of the feeders. So this is that 1 to 6% loss. If you recollect in the slide which I showed you, the distribution losses are 1 to 6%. See, if you know in a day, if there are 1 lakh units consumed by that industry, 6% means 6,000 units going as loss in the distribution cables. 1% means 1,000. It is desirable to minimize the losses to, let us say, middle of the way. 3% means you will have a saving of 3,000 units per day. At today, like 7 rupees in Tamil Nadu, I don't know about Maharashtra, maybe 8 rupees. So you will have about 25,000 rupees saving per day for each industry which is consuming 1 lakh units, if you are able to reduce the line losses from 6% to 3%. So this is one important audit point. Whenever you go as a team or in the future in your employment, you go to an industry, either as an auditor or even as an employee working in maintenance, my suggestion is please consider type 2 coordination, line losses in every feeder, so that you are able to take care of voltage quality, power quality and losses in the system. So you can read more about this. In case you want any paper material, reading material, I am here to supply that. The important thing about my classes or my interactions is that almost for everything, I have to give a documentary evidence. If you recollect my qualification, Sachin Shelar was reading, it's a BSc Physics. So I have not gone to an engineering college. Since I do not have an engineering degree, I can't tell you, I am telling you, you take it. Like most of your faculty will be telling you. So I have the unique, unhappy distinction of having to provide documentary evidence for everything that I learn, everything I put to practice, and everything I have to prove to you. So everyone who is writing to me or everyone who wants me to share from where I learned, I have to give you documentary evidence or documentary support. So in that sense, I am ready. I learned in the Google University. So I'm having no shame in admitting it and also assuring you that I will be able to share from where I learned these informations. So when we come to some standards on power quality particularly, up to now you have seen some sharing of some practical studies. Now let us take a look at the power quality issues. See, most of the power quality issues in factories are classified very simply as power factor, voltage variations, voltage imbalance, equipment loads, harmonic distortion, sags and swells, under or over voltage, transients, frequency deviations, and harmonics. So each of this topic has in some way or other impacts on the performance of the equipment and also on the energy. So you have to give adequate importance to these topics. The more you learn, the more you apply, the more you practice, you will be able to quickly arrive at what is the problem facing the industry or the equipment. In the end, I am sharing my LinkedIn address, profile. I have written more than 100 case studies. Later on, when you have an opportunity to talk to Mr. Sachin Shelar, he will tell you he's also been following me. More than 100 case studies. Each one, I call them as case slet, C-A-S-E-L-E-T. Case slet means small case studies. So each of these case studies is not more than 1,300 words, 2 pictures, and I will try to bring out what crossed my path, what learning I had for me to come out and share the caselet. So you will get an idea about what are all the topics on which I am writing, and sure you can write to me about from where I learned, what was the backup reading I heard, from where I learned. I also go to academicians. I go to IIT Madras, I go to IISc Bangalore, I go to PhD College of Technology, engage them in talks, engage them in discussions, learn from them, get suggestions from them regarding books or periodicals from where I get this knowledge, and then I go on to present to my audience. Today, when we talk about power quality, there are 3 global standards in front of us. I'm not going to bore you with the complete details, but for you to pursue, these standards are available. I'm sure Sachin Shelar, with his PQ lab and efforts that he has already made, I requested him to share the list of tools that he has already purchased, and I am flabbergasted at the modern latest equipments which conform to the latest standards that he has already acquired, and I'm sure he will be able to give you a lot of input on this. But I'm making a mention so that you remember to ask him for more input. IEEE 519-2014 is the standard for harmonics. IEC 61000-4-30 Class A Edition 3 is the standard for measuring tools. Today, CEA, Central Electricity Authority, has come with an amendment in 2019 to the regulation in which they have categorically mentioned that Edition 3 Class A has to be used and continuous monitoring of harmonic has to be made by the industries. Industries also including the generating stations like solar, wind, and so on. And the standard also is going to cover the requirement for power quality because of the incidence of electrical vehicle charging. So these are the future for the power quality. A lot of informations are available. Similarly, for power quality in general, we have IEEE 1159 or EN 50160, which prescribes the limits for various parameters of power quality. So 1 or 2 slides are there on this topic. I'm not going to bore you with details, but this is what is going to form the base for our discussing regarding power quality. If you remember the title of this program, it is Power Study and Power Quality Study. So we'll go on. This is the IEEE 519-2014 limits. We have 2 limits or 3 in actual. One is the total harmonic distortion in percentage for various levels of kilowatt ratings. It is presently available in India for 11 kV and above as per the 2019 amendment, and therefore this is what is applicable. 5% THD-V, THD-V or THD-U, face-to-face voltage. This is the limit. Individual order of harmonic voltage limit is 3%. That is 3rd order, 5th order, 7th order. The limit is 3%. So whenever we go and make study, we'll have to understand whether it is below 5% and also individual order harmonic is below 3%. And then comes the total demand distortion, which is THD, but for instead of fundamental current, it is a load current. The denominator is a load current, and this is based on ratio of short circuit current to load current. So there are 5 slabs. Less than 20, ratio of less than 20, 20 to 50, 50 to 100, 100 to 1000, and more than 1000. So the range of TDD will be 5, 8, 12, 15, and 20. This is for industries which are more than 160 kVA. So any industry which is 230 kV or 110 kV also, more than 69 kV. So 110 also will have to follow this limit. Same ratios, but 2.5, 4, 6, 7.5, and 10. Because as the kV increases, the impedance decreases. So the source becomes stiff. So these limits are achievable. So we are discussing with many industries in 11, 22, 33, as well as 110 kV, where we are able to give them what is their limit. For example, in Tamil Nadu, which is the only state which has gone for harmonic penalty. Other states, a lot of other states have gone for kVAH billing. kVAH billing, I think I have a slide here, should include true power factor. That is the displacement power factor multiplied by the distortion power factor. Therefore, this gives rise to the true power factor. Once the true power factor is applied, the kVA will accordingly be more than the kWH. And instead of a levying penalty like they do it in Tamil Nadu Electricity Board, you will be paying a higher kVAH billing charges. So when we come to that slide, I will try and expand on this thought. But these are the 3 limits: total harmonic distortion voltage, individual voltage harmonic distortion, and the total demand distortion for current. These are the 3 limits. We'll see as we progress if we have some case studies to expand on this. This is the standard IEEE 1159 which I mentioned to you, and also EN 50160. This chart here from EN 50160 can be downloaded from this website, or you can find other sites also which can give you this. Next to the harmonic and under power quality, next to the harmonic management, the next important management is the voltage sag or dips management, because this is actually causing a lot of losses in the industries. I do not know how many of you have witnessed some of your sensitive electronic loads like the VFD loads will trip, while most of your ordinary electromechanical drive motors will be running still. Momentarily the power would have gone and come back, and if you are in the department, you would not have noticed that the power went out and came back. You would not have noticed, human eyes would not have noticed this, but the tripping would have taken place, because most of the tripping takes place under 10 milliseconds. Some of them are beyond 2 milliseconds. Between 2 to 4 milliseconds, the power can go and come back, and suddenly you will have tripping of your sensitive electronic loads. This is the case with most of the VFD loads. So some of you industry people who are here, if you have had this experience, you will now know the attribute is to the sudden drop in voltage or voltage sag or dip. This can be measured using a power analyzer. So I'll try and show a case study here. Same hospital, 6:45 p.m. to 6:45 p.m. on 29/7 to 37, 24-hour reading. They have encountered a dip in voltage in one of the 4 phases, as you can notice here. Cursor half cycle is 10 millisecond, right? So the cursor half cycle has captured this. And there was a sudden dip at around 1:20 p.m. And since this hospital does not have too many sensitive electronic loads, they have only some window ACs which are VFD controlled. ACs have tripped, and normally our practice is we come if the AC is tripped, we don't even check why it has tripped, we switch it on, put the MCB back on and start using the supply. So this is a typical case study. I've used the same, like I said, 24-hour window recording in the same facility of the hospital to bring out this topic also. So power quality is a topic which we need to address when it comes to voltage sag and voltage well also. This is the harmonic THD. Now the tool which I am using is not class A and it does not measure TDD, it measures THD. It's possible for me to calculate using an Excel because this THD is with the denominator, fundamental current. But if I know the load current for that day, then use the average load current to work out this TDD value. It is possible for me to side by side calculate the TDD also against the THD values. Whereas in the Fluke 438 or 435-2 class A, which Sachin Shelar has, it is possible to directly measure the TDD values. The limits are mentioned under TDD, therefore one has to be very careful about using the limits properly and interpreting it. So what is the solution for the hospital? We found out that, as you can see here, that they had at one point of time, with the capacitors on, plain capacitors, 8.1%. May I request someone who has switched on the mic to put it off, please? There is a disturbance. Please. Thank you.
Yes, I have muted him.
Yeah. So when the capacitor was on, the THDI was measured as 8.1. See, TDD will be less than THD, so we did not caution the customer to reduce the harmonic limit. But then what we found out was when the capacitor is switched off, the same THDI value comes down to 3.1. I have a couple of slides as to why this happens. We'll discuss that. But what we gave this customer a suggestion is to go for detuned reactors. Instead of having plain capacitors, we suggested them to have reactors and capacitors in series so that they will be able to reduce the harmonics. At one particular point in time, we also found out, this was another occasion when we did this analysis, the harmonic was 10.79 and 10.8%. So detuned reactor alone was the recommendation made to this facility. Now, there are two distinctive ill effects by the harmonic, and I thought it is important for you to visually see it and appreciate it. See, when you use a DC current on a conductor, you will find that the entire conductor cross section, the current will flow. Whereas when you go to an AC current, the current will flow closer to the periphery. So the core will be cooler. You must have seen this in most of the cables. When you touch the cable, you will feel the heat, but the core of the cable will not have this heat. If you have a 250 Hertz harmonic current, fifth order harmonic current very high, you notice that it flows only across the cross section. So we talked about upsizing. Here, the upsizing alone will not help us to reduce the I2R losses. Now, the worst enemy for resistance, as you all know, is also temperature. So if the temperature is going to go up, the resistance is going to go up. We are talking about upsizing as an opportunity for energy saving, but that alone is not sufficient. So wherever we use devices operated through VFDs or SMPS, we should use metal braided cables or cables recommended by the manufacturers. Ordinary PVC or XLPE cables are not sufficient. So skin effect is one effect which causes a lot of distribution losses. Now I spoke about capacitor, plain capacitors amplifying harmonic. So we need to address this capacitive impedance, which causes the plain capacitors to become a low impedance path in a network. See, typically, if you look at the harmonic, the voltage harmonic is spreading parallel circuit. Current harmonic goes from where it is generated towards the grid. The line of its process is through the cable to bus bar to switches to transformer to the grid. That is the reason why the TDD limit is prescribed and it has to be reduced. When you reduce the TDD, automatically the THD voltage will also get reduced. And the THD voltage is a parallel branch activity. So it will spread from one branch of the network to the another branch. So while it is happening, the current, when it is traversing towards the grid, if it finds a low impedance, it's a low impedance path. If it finds another low impedance path, like a capacitor, it will flow through the capacitor, causing one, damage to the capacitor elements, two, the capacitor will amplify because of the effects. So what we recommend, as you can see here, whenever we make an audit, we switch off the capacitor and make measurements, and then we switch on the capacitors and make measurements to understand what is the distortion in waveform, as you can see here, and also the amplification of harmonics. See, when the capacitors were switched off, 3.4, 3.5%, the same hospital facility which I am talking about. So 3.4, 3.5%, 3.8% becomes 21, 23%. So we have to be very careful about choosing, plain capacitors. We need to detune. When we detune, the reactors provide high impedance, which will reflect the harmonic current to flow towards the grid as originally it was supposed to. So as you can see here, this is another site, 560 kVAr capacitors on. You will notice that the 11th order harmonic, see your 5th order harmonic is very high because of the 6 pulse drive. 7 is less than 5th order. 9 is even less, triple harmonic. But the 11th order picks up. In these two slides you can see here. Capacitor on, capacitor off. So it basically means that the amplification takes place here. The resonance takes place at the 11th order, which is the normal, normal observation when it comes to capacitors. So the capacitors in the circuit should not be plain. They should be used with the detuned reactors. So to avoid resonance, we need to have capacitors in series with the reactors, or you can have detuned APFC. When you say detuned APFC, you will have one compartment for reactors, one compartment in the behind is the capacitor, the contactors are here, and the main incomer is here. So 3-panel. This is what is recommended by the most of the state chief electrical inspectors when it comes to detuned APFCs. And there should be sufficient cooling fans at the top. See, the most preferable is to have the cooling fans at the top rather than at the rear using louvers. You can have louvers, but the fan should be at the top because the hot air being lighter, it goes up, and it is always important to exhaust them through the fans at the top. Similarly, all the reactors should be on one side. The capacitors should not be placed here because capacitors are suitable only for 40 to 50 degrees centigrade. These temperatures can be 60 to 70 degrees centigrade, and capacitor life can be lost if they are in the path of the hot air. So these two are very important. Even here, as you notice, the reactors are on the top, the capacitors are placed slightly away in the hot air, and the fan is at the top. This is recommended very strongly as a practice by the panel manufacturers. So this is the power factor, evolution of power factor, so called. So with the linear and non-linear loads, I don't know how the college will react to my using this analogy, but then I don't find a better analogy than this. If you ask Jeyaram Srinivasan, the Edison expert, he'll probably give you an analogy which will not talk about a beer. So as the example shows, the useful part of the beverage is the active power. The unuseful part of the beverage is the reactive power, but we pay for all when we buy it. So similarly, kVA is what we are contracting to receive from the electricity board. Kilowatt is what we actually put to useful work, and reactive power is the kVAR. This is the classic power triangle where the relationship we denote kVA by S, kilowatt by P, and kVAR by Q. So the relationship is S is equal to square root of P square plus Q square. Whereas in the new power triangle, we now have two reactive values. One is the distortion power, the other is the reactive power. The distortion power is the additional power generated because of skin effect and the sixth order negative sequence harmonic. So because of that, you have one additional element added to the power. So now the revised power triangle or new power triangle, S kVA will be equal to square root of P square plus Q square plus D square. So this D square is distortion power newly added. Now this is what is going to cause kVAH to be more than the kWH. So not only power factor, we also have to minimize the distortion factor. So this is the importance for states which have gone for kVAH billing to also address the distortion factor. In some factories, I show one case study where this distinction was clearly visible to us. But in a few cases, in Andhra Pradesh where there is Andhra Pradesh or Telangana where there is kVAH billing, our meter was configured to capture the distortion power, but the electricity board meter, trivector meter, was not configured, or their software was not configured to capture the distortion power. So they continue to address only the displacement power factor, PF only. The harmonic distortion power factor was not addressed. So that also happens, but when you go for an audit, look for a clue as to how this kVAH is going to be impacted because of the distortion factor. So if you look at the solution, already discussed, plain capacitors, we add fuel to fire. With the detuned filter, we are preventing the fuel added to the fire because harmonic itself is a fire. When you do a complete analysis and solution, including the detuned reactor plus the active harmonic filter, we don't add any fuel, we add water to the fire. So this is the solution concept. I borrowed this slide from Mr. M.R. Srinivasan, who is my guru for harmonic. Now I am discussing one case study of a 33 kV facility in Andhra Pradesh where kVAH billing is there. So this is 33 kV point of common coupling. There are two transformers and this facility had very high, almost 18-19% harmonic, and the kVAH was much higher than the kWH. More importantly, the client called us after facing very high failure of the boards, PCBs. Almost they were spending about 50 lakhs for PCB failures, and they had 10 lines of equipment. Each line of equipments were managed through an MCC. So we're talking about 10 MCCs, 4 chillers, and the rest of the company with a big compressor also and a standby generator. So after doing a thorough analysis for this industry, in order to address both parallel branch, they already had a detuned APFC. In spite of that, they had 19%. So in order to address the parallel branch harmonic flowing between one to another and then causing all the failures, so what we did was to go for 60 ampere active harmonic filter at each MCC level. And then these are also VFD driven chillers. Therefore, 4 numbers 60 ampere active harmonic filters at this level. And in this bus, we introduce 2 numbers of 300 ampere active harmonic filter. So apart from the detuned APFC originally conceived and put in the plant, we had to introduce so many active harmonic filters in order to prevent one, failure of PCBs, and also bring down the harmonic across the cross section of the network, and also reduce the harmonic at the point of common coupling level from something like 18% to less than 5%. So see the results. This is the result. Without the active harmonic filters, the THDI was average 18.7, 17.1 and 17.2. And the kVAH for that 1 hour was 610 units. This was based on a full day reading. I normally go to a site and then connect a meter for a full day recording, with which I am able to do a variety of interpretation and recommendation. You have seen that today in my presentation, that in the hospital 24-hour recording has been useful for variety of interpretations like KVA, demand, power factor, harmonic factor, the voltage dip, and so on and so forth. So 4 or 5 variety of quality and power can be presented using one single 24 window data. So this is based on that, but I have given you a shortcut here. So 610 units was the difference between kVAH and kWh each hour. After the active harmonic filters were installed, the harmonic came down to less than 4%. And the number of unit difference, you cannot make it 0, it came down to approximately 460 per hour. So from 610 it came down to 150. So this 460 gives you a cost saving at rupees 632 tariff of about 10 lakhs per annum. Now this is not 10 lakhs, the investment was close to 60 lakhs for all the filters and facility and the air conditioning that was created for the 300 ampere filter, active harmonic filters and all that. But then the fact is, after this has been done, it is almost, if I am not mistaken, it is almost 5 years since we did it. The PCB failure has come down to virtually zero. Virtually zero. I mean, still touch with the concerned engineering manager, and it gives me the encouragement that each time I speak with him, he says, no PCB failure, we are having a very good productivity and all that. So PCB, they used to spend about 45 lakhs every year for replacement and repair. So that is gone now in 4 or 5 years time, and every year 10 lakhs of energy saving has been made. And this industry, because of the compulsions of having to keep their productivity efficiency high, have gone in for our recommendation and successfully implemented the energy savings. Now we go to the motor driven systems. This is my pet topic. I will try and be a little breezy. Can somebody please tell me what is the time now?
Sir, it is 12:38. We were also not seeing the time, but just now, as you said, we saw it's 12:38. But it's wonderful. You are giving the information. We have lost the track of time.
Should I carry on, or how do we do it?
Yes, sir. Yes, sir. Yes. Please go ahead.
I apologize to those students who are very unhappy with the time management. Thank you for being patient with me. Thank you for being patient with me.
Wonderful knowledge.
Thank you. A few slides, I'll try and increase the pace and complete it. Motors and motor-driven systems. So for any energy efficiency today in our country, we are looking at IE3 motors. Although IE4 motors have come as per the standards, I have some reservations regarding freely using IE4. Another occasion we'll discuss why I have reservations about IE4, although IE4 are higher efficiency than IE3. Along with IE4, we need to introduce a few protection control components and certain limitations in manufacturing in this country when it comes to vendors. So therefore IE4 can wait a little longer. Today freely IE3 has matured. A lot of manufacturers have made very good manufacturing products, and you can use IE3, upgrade all your motors. And the growth of VFDs are much more than the motor growth year on year, meaning even for existing motors VFDs are being used. One or two word of cautions I will add as we go along. Use IE3, use VFD, but when you use IE3 new motors, ensure that the motors are VFD suitable or VFD ready motors. So one commentary on the induction motor. The induction motor technology is a saturated technology. They are robust, durable, and they can be returned after repair or rewinding, which is what is the normal practice in industries. When you go to the industries, you will find that this is what is normally happening. Motors' whole-time job is to deliver what the load demands. They won't deliver all that they have. They will deliver only what is demanded from them by the load. And their own self-losses, as you saw in the first slide, 85 to 96% is the efficiency. Their own self-losses would be 30% to 3%. We can't reduce from 30 to 3, but we can always attempt reduction. When it comes to 30, 10% reduction is possible. When it is 3, approximately 1% reduction in losses is possible. I have said here they are sometimes misapplied, but in my experience, most of the time they are misapplied. So application of selection application is very important. We will have another session for that for all those important, interested people. Right now we have a shortage of time, so we'll move on. So what are the other technologies available? When I said this technology is saturated, it is more than 130 years old, induction motors, whereas we now have permanent magnet motors and switched reluctance motors. These two are new technologies. And in terms of efficiency, as you can see here, high peak efficiency, on a scale of 1 to 3, the highest efficiency is permanent magnet, followed by switched reluctance, and then only induction motors. So induction motors have limitations when it comes to growth in IE standards. They are very good for IE4. Beyond that, they are not going to be suitable. So if you are going to look for IE5, IE6 efficiencies as the progressive days are coming, we will require new technologies like permanent magnet technology or switched reluctance technology. So this is just as a commentary. This is not going to be a detail. Similarly, what about the loads? Loads place power demand on motors. So it is the load which is responsible for consuming energy. So when you do an energy audit, don't say motors are consuming energy. Say the motor is delivering the energy demanded by the motor, and therefore whatever energy saving that we are going to attempt will have to be in the total system, not just the motor. This is another fact which I have to tell you. In most of the industries, whenever people talk about energy conservation or energy efficiency, the first people who put out their hands and come forward to undertake the task is the electrical engineers. The mechanical engineers and the process chemical engineers will not even bother about this. This is a sad part of the story, because it is the process and the next transmission people, mechanical people, who are responsible for typical operation of a system and therefore the energy consumption. This is not to say that the electrical engineers are not supposed to be over enthusiastic, continue to be over enthusiastic, continue to learn, continue to support. You are the most important person for energy accounting. Nobody else will do the energy accounting, if you remember the energy accounting. So energy accounting, energy conservation, you will be the most knowledgeable, most useful person. But fact remains that the energy conservation or energy efficiency will come from equally from mechanical and process people. So a few slides, couple of slides in which I will be discussing that. One point I'm trying to make here is one case example of a fan here. The input power is 60 kilowatt. The equivalent output work done is only 37.1 kilowatt. I'm not going to expand this in this class because already I overshot the time. So the fact is 37.1 divided by 60 is 56.4%. So you can see the energy loss, almost 44% is the energy loss here. We can recover even as high as 25% from here, from one single system, and the losses are distributed across. So it is the impeller and the optimum use of this fan which will help you to save this energy. So we will discuss this another occasion, or in case you want this to be expanded, I can give you some case studies and explain to you. So in terms of energy use, I am not saying consumption, in terms of energy conversion, motors are the most important with around 70%. This graph shows 74. This is in India. This is a global average. 70% of the power, 69, 70% will go through motors, 12% on electrolytic process. Heating, induction heating is 11%. Others, including lighting, IT loads, will be 8%. So this 100, out of this 100, around 70% are in India, around 74% are fed through motors, and in that sense, motors are the most important implement, and a motor system will offer you a sizable reduction in energy efficiency. There is a code project written by the Bureau of Energy Efficiency for electric motors. keep looking for this in the internet. In case you don't find it, write to me. I will share the copy with you. There is a written document, 34 pages, which explains the on-site efficiency estimation of motors. Very critical for you to apply for medium and large motors when you have to do a complete analysis of the motor and motor system and recommend to the industry to undertake energy efficiency with new motors and new systems. Some of the tools which we use for on-site efficiency estimation are power analyzer, a stroboscope, a micrometer, and a non-contact thermometer. We also use thermography camera nowadays, with which we do an analysis and explain to the customer as to what they can do with the system. I have a couple of slides on what on-site efficiency estimation really does. In my over enthusiasm, I have taken a 500 kilowatt motor here, which is a HT motor, 6.6 kV, and where we have made measurements on load and no load. It's possible for you to repeat this. All you need is understanding. If you recollect what I mentioned to you in this BW code, I have been practicing this since 2002 after learning it from International Energy Initiative, Bangalore, Professor Dr. Amulya Reddy. But then in 2010, this was reduced into a code project by Devki Energy Consultancy, Professor Dr. Desai from IIT Powai. He did this work. So this is available for you. You can understand this. I'm just showing it to you. This is one skill we have where we are able to segregate all the losses, sum it up, and arrive at the motor efficiency as well as the load factor. So this motor, which is 500 kilowatt, 8 pole, 6.6 kV, whose nameplate efficiency is 93.5%, at 45%, and also due to aging, has reduced to 84.5% efficiency. So this motor is definitely a good opportunity, because today new motors TFC are available with 95 to 97% efficiency. So this is a requirement which came up from a cement plant. Customer has replaced this motor and has also reported energy saving. We do this normally for medium and large size motors which are 11 kilowatt and above. Similarly, we also do a lot of load mapping and recommending to the customer. This is Mahindra Nashik plant. Just take a look at the layout of this report. You will get a lot of information here, very useful information. We take a normal picture and a thermography picture. We put the nameplate, and then we go on to nameplate details. What about the transmission method? What is the method of starting? What is the method of coupling? And then if it is a belt, what is the pulley belt sizes? What are the measured values? And then we go on to give load factors. What is the proposal? Existing motor efficiency, new motor efficiency. What is the payback period? So such a report based on a load mapping can help the customer undertake priorities available to them for a replacement. Like I said, anything less than 4 years, people will undertake replacement of motors. Anything more than 4 years, motors will not be undertaken. Reasons for longer payback will be probably because of low number of hours of operation. So you see here, even here it is just 17 hours of operation. So if an operation is there for 24 hours, the payback will be accelerated. So my idea of showing this slide is basically to tell you that a detailed load mapping and report can help many customers understand how their assets are operating, put to use, and then how they can be replaced. So typical motor system loss in a pump. I showed you a fan. Similarly, in a pump, there are so many losses because of the drivetrain, complete drivetrain, the method of starting, motor itself, belt pulley, the valve, friction losses in the delivery side, and all those things. So typically in a motor, only 1 to 5% can be recovered in a pumping system. But if you undertake replacement of pump or partly replacing the impeller or internal coating and things like that, there's a lot of losses which can be recovered. As much as 30 to 50% reduction can be shown. Many times when we do an audit and show to our customers in a paper industry kind of situation where the pumps are very poorly maintained and operated, they are shocked. But when they take one sample as a trial and they realize the savings, then they feel that we are winning.
Hello, sir, we are unable to hear you.
You're not able to hear us?
Yeah. Now it came.
Now it's okay?
Yes, sir.
Okay. I've just shown one case study here where in a sugar plant, because you come from an area where a lot of sugar plants are there, people use medium voltage motors for boiler feed pumps. Actually today, LT motors can be given up to 1750 kilowatt 690 volts. Almost 1100 kilowatt 415 volts. The technology has cut up with the HT area. So we helped one industry wanted to go for a LT motor with VFD, boiler feed pump, because they were able to see that their HT motors were operated with the valve closed condition most of the time throughout the year crushing season. So they came forward, 3 of their pumps were replaced with LT motors, and in 2 crushing seasons, motor with VFD, they were able to recover the cost of investment. So I'm just showing only case studies where we had very big successes. So conversion of a medium voltage motor to an LT voltage motor is also a possibility which you can consider for people who are coming from that part of the country where sugar is a very popular application area. I thought I will include this slide. So while talking about the pumps, the law of affinity has also to be understood. So only one slide why I want you to understand this. For pumps, fans and centrifugal compressors, which are called as variable torque loads, VFD is an excellent choice for energy saving compared to other means of reduction in flow. See, normally what happens is all these equipments are oversized, and in the plant, people use them variably for their requirement by using a damper or a valve. So wherever you find an application where damper or valve is used, you should go for VFDs, because the VFDs will give you substantial energy saving. As per the law of affinity, flow is directly proportional to the speed. Torque is proportional to square of the speed, and power is proportional to Q of the speed. So you will find if you are able to reduce the speed by 50%, your power saving will be much higher. I don't know whether I made a mistake in using a slide here. So actually it will be much higher. So that is what I am trying to show here. We can see if there is a case study. Yes, there is one sample. See, when you use a throttle control like a valve, the energy saving available to you is only 11%. Whereas if you come here and see variable speed control for the same, see what is originally designed for 10 by 10, reduced to, let's say 7. Flow rate is reduced through throttle 7. When you throttle, the pressure will increase, it will not reduce. So the pressure has now gone up to 12.7 and the efficiency curve has shifted. Still you have a saving of 11%. But if you use a VFD and reduce the flow to 7, the pressure will not increase, pressure will reduce to 6.4. Such that you will have as much as 55% energy saving. So I want to emphasize here that in pumps applications and fan applications, where you have throttle or damper used, if you change over to a VFD and remove the throttle or valve or a damper, you will find that the energy saving is substantial. It must have been the experience of some of the industry people already. The theory behind this is this. So I wanted to basically explain this as an opportunity available. That was my last slide. Like I promised, I have mentioned my mobile number, my mail ID, and my LinkedIn ID. My request is please don't call, although I have put my mobile number here, because calling will always, I must have lost about 5-6 calls already. Oh, I've lost 16 calls. So like this, if I am engaged in some activities, I will not be able to answer you, and you will scold me for not answering your calls. Best is to send me mails or follow me on LinkedIn, where I have been sharing a lot of case studies. Thank you very much for this opportunity. I hope I was able to take you through some of the applications and knowledge I have gained through our audits. So I am ready for questions and answers. Thank you very much.
Yes, thank you, Jeyram sir. It was an excellent presentation. You gave the scope for electrical engineers. You have also shown about the theory. You have given excellent practical tips. you have explained that standards are important, and although they are not included fully in the syllabus, they should be covered, and students must go through it. Not only students, even the industry person must read the standards and apply it properly. Case studies you have given, study things, and you are studying even after 42 years of experience. This is a very, very important tips for my students who get bored after 3-4 hours for one day. So it is not like that. It is a lifelong learning, and you have to. And now you are in an era where you have a lot of information, and this kind of experts who are directly talking from Chennai to us, and this is you should take these things in a lucid way. You have explained it in a proper pace, and you have given pointers for energy and power quality audit, and I'm sure there is a takeaway for not only students but also for faculties and industries. So I now request all those who are having questions, please raise your hand so that we can take it one by one.
Should I stop sharing my screen?
Yes, sir, please.
How do I do that?
You again go to that sharing screen button. You end it now. First you end this, escape. You can put escape. End show.
Yeah, I think I have done it.
And now you unshare the screen.
Yeah.
So anyone has questions, either you write it in chat or you can raise your hand and you can directly talk to Srinivasan sir, students or faculty members or industry persons. Of course, sir has covered everything in a detailed manner, but if this is the opportunity to talk to sir directly. Even if you have a question about what kind of opportunities or what you should do in this remaining 1 year, especially for third year students.
I have given you one input. This is a marathon. This is not a 100-meter dash.
Yes.
So take it easy. Between 1 to 5 years, build your career. Understand which path you want to choose. Multiple choices are there. Choose with passion what you would like to pursue. And in 1 to 5 years, equip yourself. But one thing I liked in what Mr. Sachin Shelar said: do not stop reading. I average 2 hours every day. Even my own son, who is just passed his BE mechanical engineering, does not read as much. Very important that we read, reread.
True, sir. Even nowadays, it's you have to unlearn the things and you have to learn new things. That has come up.
Correct.
Any questions? I'm sure some of don't shy. You have this opportunity. You can unmute yourself and talk. I think everybody has understood everything. Yeah, go ahead, please. Who is it?
Srikant Deshpande, sir. Hello.
Yes, please go ahead, sir.
Hello, sir. My question is during
sir,
your presentation, sir, you said, yes, I am a Srikant Deshpande, working as a deputy executive engineer in MSTCL, Maharashtra State Electricity Transmission Company. And my question to Srinivasan sir is that during his slide of power quality audit, he said power quality audit should be done without capacitors already existed and with capacitors also. And what is that? Why?
Sir, actually, in some industries, when we give solution, we need not propose active harmonic filtering at all. If you know that the industry is in the border and all the capacitors are plain capacitors, to prove to the industry that the plain capacitors, when they are converted into detuned filters, the harmonic will come down because the plain capacitors are amplifying due to resonance. So to prove to the industry where we are doing the analysis for less than 5 minutes, because the demand should not shoot up, we conduct this with and without capacitor study. And we always importantly keep the electrical engineer or electrical manager next to us while the study is conducted, so that they can witness it on the power analyzer. So this is the logic behind with and without capacitor. Solutions can be with the detuned filter, which is low cost solution.
Okay, sir. Understood. Thank you.
Thank you, sir. Thank you, sir. Thank you, Jeyaram. Any other questions? Meanwhile, I have also put up a feedback link in the chat section. Please go for the feedback. At the end, you will get the certificate. I think in chat box, one of my student Deepjot is asking, when selecting low or moderate or high cost solutions for a problem, are the low cost solutions that effective when compared to high cost?
No, actually, it is not an alternate. Instead of low cost, select high cost, or instead of high cost, select low cost. No. What I meant was that our solutions will have to be classified into 3 areas. Like I said, low hanging fruits, some best practices, like buying a good quality bearing, buying a good quality grease by itself, or disciplining the way you work in the field or in the industry can help you to recover some cost. That could be 2 to 5%, not more than that. That is what I call as low cost. That's a choice one available, which I'm sure most of the industry people will immediately adopt. If they learn, if they understand, they immediately adopt. The high cost ones are complete replacement of machinery or a process line, like a dryer or a cooling tower or a machine, production machine, so on and so forth. Those are high cost. You may suggest that if you are a specialist on the process, you may suggest a replacement, but the industry will look at it as a high cost intervention and postpone, may not easily agree with what you are saying, because many other parameters have to be considered for implementing that suggestion. So my idea is not alternatively, my idea is 3 distinctive areas of suggestions: low cost, low hanging fruits, immediate payback; medium cost, medium payback; high cost, long term payback. If you show a payback of 8 years, that will not even be touched. So this is the practice that I am trying to explain.
Yeah, we are very much economically sensitive.
We are a low cost country with a lot of low cost demands. So
True, sir. True.
it will be difficult to deal with Indian maintenance people. And importantly, they think anything and everything can be maintained. We are also a country where we don't throw anything. Look at your house. Your parents will never throw anything. They will think some use will be there for everything and they will retain it. And this is how clutter gets accumulated in the houses.
True. May I request our head of the department, Dr. Mrs. A.D. Sirakar, madam, to say a few words? And request all the other participants that feedback link is available in the chat. Please give your feedback. This will help you to get the certificate, as well as if the PPT shared, I will be able to share on the registered email ID. Shiraka madam, are you there?
Yes, sir. Am I audible?
Yes, ma'am, you are audible. Please go ahead.
Yes. Good afternoon, Srinivasan sir.
Good afternoon, madam.
Good afternoon, all. So, on behalf of All India Shri Shivaji Memorial Society, Institute of Information Technology, and Dr. Ashmana Shirakar, Head of Electrical Engineering Department, would like to thank you, sir, for accepting our invitation, sharing valuable time, and delivering knowledgeable talk on power quality and power quality audits in industry. Sir, your talk and discussion on case studies on power quality audits in industry will definitely help our students in their studies and the future too. So thank you, sir. I must thank Sachin Shelar, sir, our PQ cell in charge, for his efforts in arranging this expert talk. So I would like to thank you all the participants for attending this webinar and taking benefit of it and making this webinar successful. Thank you all. Thank you, sir.
Thank you, madam. Thank you. I think Jeyram sir, you have already explained so much that people don't have doubt now. They have to just learn more and more, and they will read. I'm sure. But it was wonderful experience for my students. And I was waiting for this moment for so many days. We were discussing. You must be remembering on LinkedIn or on WhatsApp. And today we had. And thank you for giving us so much time.
Thank you.
Yes, sir.
My request is I have shared the PPT by WhatsApp.
Yes, sir.
Share them with anybody, because there is not even a single PPT which is my own. There is nothing original.
Yes, sir.
Everything is from my learning, my observing and things like that. So my suggestion is you share it with anybody and everybody who asks for it. You have
Thank
it
you
in
very
your
much.
WhatsApp, and if that can trigger questions, my suggestion is they need not even come back to me. Already 6 people have sent friend requests to me for LinkedIn. I've already accepted them. So
Yes,
I
sir.
appreciate this. Students, even in the classroom, don't generally exchange or ask questions. They go through in the motion. The doubts will come much later. So if the PPTs are shared and if they get doubts, my suggestion is first they can come to you. You can explain to them with your whatever books and periodicals that you have. Beyond that, if you think it is going to be useful for me to get involved, please write to me. I'll be happy to share it with you. Thank you for this opportunity.
Thank you, sir.
Like you rightly said, it is my passion which brings me here and speak for 2 hours.
Yes,
So
sir. Yes, sir.
I hope God gives me life and breath to
So
continue to do
we'll
this on
wait
your
for
behalf.
that.
Yes,
Thank you.
sir. Yes.
Thank
Yes.
you,
Once
madam.
again, thank you, sir. Once again,
My
thank you.
pleasure.
Yes.
Thank you.
My
Thank
pleasure.
you, sir. Thank you to participants as well. And thank you to head of the department or principal and management who encourage us to do the understanding. And the main thanks to Jeyram sir for giving us this much time.
My pleasure.
Thank
Thank
you,
you.
sir.
Thank
Okay,
you.
sir.
Bye-bye. Bye-bye.
Yes, sir.